Okay, welcome to this video where we're going to look at this exam question about filling in a table of values and then plotting the graph of a function which is defined here. Okay, we're also going to answer various questions relating to solutions of graphs that cross the graph of this function. All right, one thing at a time. Let's start with the basic completion of the table which it's asking us to do. All right, so what we have to do here is to complete this table without a calculator, because this could be a non-calculator paper. We would have to take each of these x values and substitute them into here to find out what y is. So let's just do the first one, which is f of minus 2. So f of minus 2 just simply means replaced x with minus 2 in the function. So f of minus 2 is simply going to be minus 2 squared. Notice we must square the whole thing, including the negative. Okay, minus 2 lots of minus 2. Okay, take away 3. Now, if we work that out, that gives us minus 2 squared is minus 2 times minus 2, which is plus 4. Okay, minus 2 lots of minus 2. Again, you're timesing a minus by a minus. That's going to be plus 4. And then we've got minus 3 here. So that's 4 plus 4 is 8, minus 3 is 5. Okay, so when x is minus 2, f of x, or y, is 5. Okay, now we do the same sort of thing with minus 1. I'll just do the same process here. Okay, and that's going to give us negative 1 squared. Okay, we'll do this as we go. Negative 1 squared is 1. Okay, take away 2 lots of negative 1. Well, that's like adding 2. So it's 1 plus 2 is 3. Take away 3 is 0. So we did that one as we went along, and that's 0. Okay, 0 has been done for us to give us minus 3. You can check it if you want. 0 squared minus 2 zeros, that's 0 minus 0. Minus 3 is indeed minus 3. Now we put 1 in. Gets a bit easier with the positive numbers. Okay, so let's do them all. F of 1, okay, is equal to 1 squared. No brackets needed now because it's a positive number. Minus 2 lots of 1, okay, minus 3. Well, that's going to be 1. Take away 2, which is minus 1. Minus the 3 is going to take us to minus 4. Okay, so minus 4 goes in there. Okay, when we do 2, we would find that we get f of 2 equals 2 squared, which is 4. Take away 2 lots of 2, which is another 4. So that's 4. Take away 4 is 0. Take away 3 is going to be minus 3. Okay, and that one goes in there. Now you may notice now there's a symmetrical pattern forming. Look, 5, 0, minus 3, minus 4, minus 3, 0. And you suspect the next one would be 5, and it will be indeed 5. Okay, because all quadratic functions have this symmetrical pattern about them. Okay, now we plot these points on here. Just one word about this. If this was a calculator paper, you can set up a table function on the calculator very easily that would give you these answers in one easy process. But let's continue with this. So we plot the points quite literally as little crosses in the right place. So the first point is that one there. The second point, negative 1, 0, is here. Okay, the third one is 0, 3, which is, sorry, 0, negative 3, which is down here. Then we have 1, negative 4. Then we have 2, negative 3. And then we have 3, 0. Okay, and finally 4, 5, which is up here. Okay, so you should see a smooth symmetrical curve shape. If you don't, you've plotted one of the points wrongly if it's a quadratic, which this is. Now, this is really difficult using a tablet and a pen, and I'm going to be able to make an attempt at it, but it won't be as good as what you could do on paper, because on paper you can turn the paper sideways or even upside down to create a really nice smooth curve. But I will do the best I can with this, but it's not likely to be anywhere near as good as it would have been on using pencil and paper, I should say. Okay, I'm going to do my best. So I'm coming from this point, almost a straight line down to here, okay, and then it continues almost straight, starts to curve. When you get to the bottom here, you want to try and smooth out the bottom of the curve before you climb up. A common mistake is to have a big sharp point at the bottom, which you don't want to have. Carry on up there and then continue in a straight line, well, as best you can to there. Now that actually, using a drawing tablet, isn't too bad, but I'm going to completely cheat now, all right? That's what it would look like roughly. As I said, the main thing to avoid is having a sharp sort of point here at the bottom. And the other problem that you often get, which I'll just illustrate to you now, is you get too much curving and you get this sort of effect. I'll do it in a different color. So these are the bad things to do, is you go have a sort of a like this, and then it comes out and goes in again like this, and then it goes down like this, and it's too sharp and it comes up like this. That sort of thing you want to avoid. Anyway, let's take away this, and to make the rest of this question look really good, okay, this is going to be replaced by something a little bit better, which is about to appear from the right, and there it is. So if I had a steady hand, that would have been my perfect sketch for that graph. Okay, now moving on, I've done part B, and I've now got to write down the solutions of the equation f of x equals 0. Well, f of x equals 0 means that the function equals 0. That's on the y-axis, and that happens in two places, okay, where it crosses the x-axis. Here it's -1, and here it's 3. So the answer to part C is x equals -1 and x equals 3. So those are the two solutions of the quadratic equation as it stands. Now it says write down, implying that they are exact and that you can easily see what they are. And you can see that that's -1 and that is 3. Okay. Now, in the next part, it says, by drawing a suitable line on the graph, estimate the solutions to that. Now, what you're going to do is you're going to recognize that this is the function y equals x squared minus 2x minus 3. So you're now going to draw the line y equals 2.5 on the same graph, okay? And that is a line that goes through 2.5 on the y-axis. So it's this line here, okay? Now, I've drawn the line. Now what I've got to do is estimate where that line crosses the quadratic curve. So I'm looking at these 2 points here, okay, and I'm estimating what they are. And I would suggest that the x-coordinate of that is -1.5, and this one is, well, it looks to be about 3.5. Yep, that's 3 there, so 3.5, maybe slightly over 3.6. So for part D, using my graph over there, okay, I'm going to say that x is, now I'll show you how we write this, x is approximately equal to negative, I'm going to say negative 1.6 because it's slightly below 1.5, or x is approximately equal to 3.6. Okay, there will be some leeway on this because of your own sketch graph. They allow a tolerance here, but what they'll be looking for is evidence that you've drawn that line on and it's the correct line. And finally, another suitable line on the graph to estimate the solutions to this. Now the line that will be needed here would be the line y equals minus x minus 2. Well, this has a gradient of minus 1, okay, because it's minus 1x, and it cuts the y-axis at minus 2. So it's a line, a straight line, that goes through the x-axis, sorry, the y-axis at minus 2, and it has a gradient of minus 1. So it's this line here, okay? So it's going to go through minus 2, and it's going to cut the y-axis at minus 2 like that. Okay, so what we're interested now is where that blue line intersects the quadratic. So I'm looking at that point there and that point there. Okay, and I'm looking for the x values. Well, it's only an estimate, but that to me looks like if I project it vertically upwards, okay, if I just do this, yeah, I'll leave it in the blue color, maybe just do a thinner line. So if I went up from there to the x-axis, see where that's crossing, it looks like about, there's 1, it looks like about negative 0.6, okay, and this one here looks like about, well, that's 1, 1.6, 1.7, okay. So it's probably about 1.6 or 1.7. So 1.6 and negative 0.6. So I'll write finally here that for part E, x is approximately equal to negative 0.6 and x is approximately equal to 1.6. Okay, and that's how you would answer that question. But really importantly, leave these lines on your graph because this is evidence that you've used the correct method and shown your working. Okay, that's the end of that question.